The Transonic Perivascular Flowmeter is used with a suitable flow probe positioned around a single vessel to measure blood flow. Analog outputs allow for direct connection to a power lab. In LabChart, the mean blood flow, heart rate, stroke volume, and cardiac output can be calculated in real time. We begin by connecting the power cord. Next, connect the BNC flow output to a power lab. Then, connect a flow probe to the front panel and power on both the module and the power lab. The display will scroll the probe size and no signal until liquid is present in the flow probe. Next, immerse the probe in degassed water, dislodge any air bubbles from the surface of the probe, and observe the front panel indicators on the flow module in test mode. In the top left corner, the bars of the signal quality indicator should be fully illuminated and the digital display will read good signal. In LabChart, I've set the range at 2 volts and the scale at 50:1. Notice the background signal and that the units are in volts, so our next step will be to convert the units to milliliters per minute. While the flow probe is steady, press the mode button to 0. 0 will cause the needles to deflect back to 0 volts, and 0 will be displayed on the digital display. In LabChart, the signal will read 0, and let's add a comment. Now, press the mode button to scale, and the display will indicate the volts to flow conversion for this probe, which is 100 milliliters per minute. The analog meter will deflect to 1 volt, and the analog output to LabChart will read 1 volt. Let's add another comment here, then click Stop. To convert the units to milliliters per minute in LabChart, select an area of data containing both the 0 and scale measurements of 0 and 100 milliliters per minute. From the channel drop-down menu, select Units Conversion and perform a 2-point calibration into milliliters per minute. Be certain to select data from the steady portions at 0 and 1 volt. Back in measure mode, the digital display will present the average volume flow in milliliters per minute. The analog meter will register flow proportional to the flow probe scale, and the signal quality indicator will again be illuminated to monitor acoustic coupling. There are a few more options available to us on the flow meter: filter, invert flow, and low range. First, let's choose a filter setting, then move the probe back and forth in the water. Notice the digital display will change slowly due to the averaging process as the flow meter measures flow. The analog meter will move rapidly, indicating instantaneous pulsatile flow. Next, invert reverses the flow signal if needed, instead of reorienting the flow probe on the vessel. And finally, low range reduces the range of the flow probe to a quarter scale to measure lower flow rates when needed. Notice the change in sensitivity. Keep in mind, if you choose to use low range, you will need to adjust your units conversion in LabChart accordingly. For this probe, the low range conversion would be 25 milliliters per minute to 1 volt. We've now completed the setup and units conversion for the perivascular flowmeter. We are ready to place the probe and collect volume flow measurements. And whenever you have questions, be sure to ask your AD Instruments support representative.